Hi GOH, this is Unit 4, Lesson 6, and today we're going to construct the inscribed circle of a triangle. So a few days ago we circumscribed a circle, okay, and today we're going to do an inscribed circle. So we're going to see that for every triangle there is a unique circle that lies inside the triangle known as the inscribed circle or incircle. This circle is tangent. Now the word tangent we're going to do when we do circles later on, but that means it just touches. It doesn't cross over, it just touches. The circle is tangent, just touching but not crossing to all three sides of the triangle. So based on that definition, which of the following diagrams shows a circle inscribed inside of a triangle? So each side of the circle is sort of touching the side of the triangle. Okay, hopefully you guys are looking at these and you're trying to see which circle is inscribed inside, and that would be choice 3. That circle is inscribed inside of the triangle. All right, so now we're going to do that construction. The key to finding the center of the inscribed circle is the construction of the angle bisector. Now the angle bisector was actually a pretty fun one to do. So we're going to do that for triangle ABC down below here. We're going to construct the angle bisectors of angle A and angle B. So remember, I open up my compass, I put it on A, the angle I'm trying to bisect. I draw an arc. That arc has to touch each side of the angle. Where it touches on the bottom, so where that first arc touches angle A on the bottom, I'm putting my compass and I'm going to draw an arc out here in the middle. And then where the first arc that I drew touches angle A on the top of the angle, the top ray, I put my compass and I draw an arc. And that point of intersection, I now connect with the vertex of the angle. And this line that I'm going to draw right here is the angle bisector. So that line is an angle bisector. I'm going to do the same thing with B. I'm going to grab a different color. I'm going to put my compass on B, and I'm going to draw an arc. It doesn't matter how big or small my compass is, but the arc needs to touch both sides of that angle that I'm trying to bisect. Now where it touches, the first arc intersects the bottom ray. I put my compass and I draw an arc out here in the middle. So all of these I'm drawing 3 arcs. The initial one, and where that initial one intersects that angle, I'm putting my compass to draw arcs 2 and 3. All right, now where that point of intersection is, I connect that with the vertex of the angle B, and that also is my angle bisector. Now make sure you draw these long enough that they intersect each other. And that point where they intersect, where the 2 angle bisectors meet, I'm going to label that point M. Okay, so this is M. All right. Now question B wants me to explain why M must be equidistant from all 3 sides of the triangle. Again, why is M equidistant from all 3 sides of the triangle? Basically, M lies on the angle bisector. Therefore, it has to be equidistant from side AC, AB, and BC. Any point that lies on the angle bisector is equidistant from the side. So it's equidistant from AC, equidistant from AB, and also equidistant from BC. Now, I need to know I'm going to inscribe a circle inside of this triangle, but I don't know the length of my radius of the circle. I have to find a line, so I need to construct a line. This is part C right here. And I'll grab a different color, I'll grab the purple. I need to construct a line that goes through M that is perpendicular to AB, because that will be the length of the radius. So from M, so I'm going to put my compass on M, I want to draw a line that is perpendicular. So keeping my compass on M, I have to open it up a little bit, because remember, if I'm going to construct a perpendicular line, it needs to go below this line. So I keep my compass on M. I'm doing this in purple. I draw an arc that falls below line AB. And then where that arc intersects, So I'm putting it where the first arc intersects A right here, and I'm drawing an arc. And then I go over to the right side where that arc intersects AB on the right side, and I'm drawing an arc. And I connect that with point M. So point M I connect. Now that line right there is perpendicular. Okay? And they wanted me to call the point where it touches, it intersects with this line right here. I'm going to call that D. Okay, so right here is point D, right there. And they want me to explain why DM represents the radius of the inscribed circle, and then I will draw that radius. So basically the length of DM, so DM I'm looking right here, is the shortest distance that M is away from AB. Because the shortest distance is a line that is perpendicular. So it's the shortest distance that M is from AB. Since M is equidistant from all sides, then DM must be the shortest distance from all three sides. So if I were to take my compass and put it on M and use a radius of DM, and then I should be able to construct this circle right here, and that circle will be inscribed into my inscribed in my triangle. So again, I'm putting it on M, and I'm going to open it up exactly to the length of DM. And if I'm like a smidge off, then this whole thing is going to be a smidge off. So I want to make sure I'm going as exact as I can. Okay, it's kind of hard to be exact with this compass on the smartboard, but let's see if that did it. Pretty close. Yep. And there I go, and my circle is inscribed in triangle ABC. All right, so that's the first page. We're just going to do one more on the next page. We'll try it one more time together to make sure you got the hang of it. We won't do exercise 3 though. And I wrote the directions right here for us. So for triangle DEF, we're going to construct a circle inscribed in the triangle. Leave all construction marks. Label the center of the circle C. So you have to construct 2 angle bisectors. I don't care which angles you pick. I'm going to pick D, and I'll probably pick F. So I'm going to go to D, and I'm going to draw an arc. I'm doing the angle bisector of angle D. I go to where that arc intersects, and I draw an arc out here. And then I go to the other point where the first arc intersects, okay, and I draw an arc out here. Where those 2 arcs meet, I now use my straight edge, and I connect that with D. And then I have to do one more angle bisector, because the point where the angle bisectors meet, that is my incenter. That's going to be the center of my circle. So I'm going to do the same thing, and I'm going to do it for F. I draw an arc. I come here to where the first arc intersects the circle. I'm going to open my compass just a little bit more just to get it away from there, and I'm going to draw an arc. Keep the same setting that I just used. When you do arcs 2 and 3, they have to have the same setting. And then that point of intersection gets connected with F. So where the 2 lines meet right there, I'm going to make a green dot just so you can see what I'm talking about. That is point C. They said to label that point in the center as C. All right, now that's not it. I can't just use that as the center of my circle. I need to know what the radius is. So I need to construct a line perpendicular from the incenter to a side. It doesn't matter which side I do it to. All right, so I'll probably just do it to DF right here. So as long as I have the green, I'll use the green. So from point C, I want a line that is perpendicular. So remember, it has to go below. I'm doing it to DF. It needs to go below the line. There we go. And it just touches. If it had gone past F, I would have just extended that side, and that would have been perfectly fine to do. Now where it touches the first arc, I'm going to open it up just a smidge. And I'm going to draw an arc here. And where the first arc touched over here on the right, I'm going to draw another arc, so the third arc. And where those meet, I'm going to connect that with point C. So this line should now be perpendicular to DF. And my line is looking a little crooked there. So let me try and fix that a little bit. So I need to move that over. Okay, and that looks okay right there. So that should be the radius of my circle right there. They said to call that A. So I'm measuring from C to where it is perpendicular at DF, so right here, okay? And I'm just going to swing this around to see if I did it. Yeah, it looks like I got it. I'm a little bit off on the top because I see as I'm swinging it around. I feel like my line is a tiny bit off. That perpendicular line is a little bit off, but if I draw this, and if you're not exact on all of them, you're going to be off. So I did hit on two sides, but on that third side I'm a little off, and I think it has to do with the fact that this line is not exactly perpendicular. So one of my measurements was off a little bit. Okay? And that's all we're going to do. We will practice that tomorrow.